We now proceed to the topic of equilibrium. For section 5.1, the first condition of equilibrium. The simplest way to determine or to define the equilibrium of a body is to say that a body is in equilibrium if it has no acceleration. That is, if the acceleration of a body is 0, then it is in equilibrium. Always remember that. Okay? Then bodies in equilibrium under a system of forces are described as a special case of Newton's second law. Ano nga yung Newton's second law? F is equals to ma. Then, ano nga yung concept of force? It's a summation of all forces, okay? Equals to ma. In a body, from your previous lesson, there's this all forces acting on a body is equals to ma, and that is still Newton's second law. So if there is no acceleration, therefore equation 5.1 says all or summation of all forces acting on a body is equal to 0. The first condition of equilibrium states that for a body to be in equilibrium, the vector sum of all forces acting on that body must be 0. So, acting all vectors or all forces acting on that body must be 0. That is the first condition of equilibrium. Now, forces that act through only one point of the body are called concurrent forces. And that portion of the study of mechanics that deals with bodies in equilibrium is called statics. When a body is at rest under a series of forces, it is sometimes said to be in static equilibrium. So one of the simplest cases of a body in equilibrium is a book resting on the table, because there is no acceleration. So the book here is at static at a static equilibrium. And the forces acting on this book are its normal force and the weight force. So taking into consideration their proper position, this is positive, so this is negative. This is why Fn or normal force is minus weight equals 0, or simply normal force is equal to weight. Now, let us consider this figure 5.2 with three forces in equilibrium. What are these three forces? This F1, F2, and F3. Halimbawa, itong F1 is a rope, and itong F2 is another rope, and then itong F3 is another rope. So, tatlong tali, yung dalawa naka-angle. Pag naka-angle, there is a x and y components of each. So, this is the F1x, F1y, and then for F2, there is F2x, and also there is F2y. For F3, since it is in the y component, it is still in F3. So, by making it into the x direction, okay, x direction is simply a summation of all forces acting on the x direction. What are these? These are the F1x and the F2x. So as you can see here in the x direction or in the x component, there are only two, namely F1x and minus F2x. And since this is in an equilibrium or in a static equilibrium, these are all equal to 0. Why? Because no acceleration. So F1x minus F2x. Similarly, for the y component, there are 3. What are these? This F3, this F2y, and this F1y. So since they are all positive, minus F3, okay? So F1y plus F2y minus F3 is 0. So as a generalization, for summation of all forces along the x component, that is 0, and summation of all components or forces all in the y components are 0. The first condition of equilibrium also states that the bodies in equilibrium of the sum of all forces in the x direction is equal to 0, and the sum of all forces in the y direction is equal to 0. Sana clear yan. Now, example 5.1, a ball hanging from a vertical rope. So there is this ball and a rope. So the forces acting on this ball is the tension force because of the rope and its weight. Now the forces along the y-axis is dalawa and then along the x-axis is 0. So we will just consider the forces along the y-axis. What are these? It's T minus W equals 0. So here it is. Pag ilipat mo yung W sa kabila, magiging T is equals to weight. Now, from the problem, a rope is hanging from a ball is hanging from a rope that is attached to the ceiling. We assume that the mass of the rope is negligible and can be ignored in the problem. Now, hindi sinabi kung ano yung weight or yung mass ng ating ball. So, the answer to this problem is simply the tension is equals to its weight. Now, the tension in the rope is equal to its weight of the ball. If the ball weighs 5 Newton, then the tension in the rope is also 5 Newton. Okay? If this is halimbawa 10 Newton, then its tension is also 10 Newton. 5.2, there is this ball hanging from a rope is pulled to the right, okay, by a horizontal force. So there is a horizontal force making the ball to the right. Now, the force F such that the rope makes an angle theta with the ceiling. So, with an angle theta, okay, with the ceiling. So, this is the ceiling. What is the tension in the rope? Now, let us focus on the time na hinila mo si bola and then nagkaroon na siya ng angle or kumbaga, angular na siya. So, there is this force. So, force na to, okay, meron kang weight and yung tension. Tension dahil dito sa rope. Ngayon, si tension mo is angle na. So, si tension mo is meron ng x ang component na tx and the y component na ty. And remember that the theta here or the angle here is equal to the angle here with regards to the x-axis. Okay? That is equal. Theta here is equals to theta here. Now, summation of all forces along the x, there is 2. The F and the Tx. So, F minus Tx is equals to 0. Okay? So, F minus Tx is equals to 0. So, ano yung ating Tx? Remember the SOHCAHTOA? So, for Ka, it is adjacent over hypotenuse. So, adjacent is Tx, okay? That is T cosine theta. Okay? Or always remember that if your theta or if your angle is with the x direction, it is cosine. Kaya siya Tx is equals to T cosine theta. Now, pag si Tx ilipat mo sa kabila, magiging positive Tx. Kaya ngayon si F is equals to Tx or simply Tx is T cosine theta. Ano si T? Itong tension ni rope. So ito na yung equation natin along the x-axis. For the y-axis, there is also 2. What are these? Ty and the w. So this is Ty minus w. Here, equals to 0. Ano yung Ty natin? So, pag si Ty and then hindi nakadikit sa kanya si angle, gamitin natin si sin theta. Yan lang para hindi kayo malito. So, T sin theta. Okay? Si Ty, ilipat natin si W sa kabila. Okay? So, Ty is equals to W. And Ty is equals to T sin theta equals W. So, there are 2 equations na. This 5.6 equation and 5.7 equation. So, therefore, in any 2 of the 4 quantities specified, there are other 2 that can be determined. Recall that in order to solve a set of algebraic equations, there must always be the same number of equations as unknowns. Ano yung unknown dito? lahat actually is unknown. But for example, ito, binigyan na tayo ng value. If yung weight down ng bola is 5 Newton and nagkaroon siya ng angle na 40 degrees from the ceiling. So, this is 40 degrees from the ceiling. What is the tension? And the force F. So, there are two unknowns, the tension and the force. Okay? Because, given tayo ng weight, so there are two unknowns or two na kailangan nating hanapin. So, therefore, we also need two equations. What are these two equations? Itong 5.6 and yung 5.7. Okay? So, ginamit niya dito is itong 5.7. Okay? Bakit niya ginamit? Kasi, since hindi tayo given ng force, okay? Force is equals to t cosine theta, but we were given with the weight. So, gamitin natin si 5.7. Now, weight, okay? Tension, sine theta equals to weight. So, ibaba mo si sine theta to get the tension. Kaya ito, sine theta is nasa ibaba. Now, 5 Newton is equals to sine 40 degrees and your tension is 7.78. Ngayon na nakuha mo na si tension, you can now use 5.6, okay, to get the force. So, what is force? Force is equals to t cosine theta, or force is equals to t cosine theta. Input the value of t cosine of 40 degrees and you will get 5.96 Newton. Example 5.3, resting in your hammock. A 68-kilogram person lies in a hammock as shown in this figure. Okay? Do yan. The rope at the person's head makes an angle of 40 degrees with the horizontal. So, where's the horizontal? Ito siya, okay? So, 40 degrees with the horizontal. So, dito na part. Pag ito-draw mo yan siya, okay? Ito yan siya, itong tuldok is yung, kumbaga, center of mass ng tao. And then, ito is yung kanyang likod na naka-angle. So, pag sinabing 40 degrees from the horizontal or with the horizontal, ito siya. 40 degrees siya dito. So, ibig sabihin, pareho sila ng angle dito. So, ito is angle dyan siya. So, may angle din siya dyan na same 40 degrees. Sa head yun na. Now, while the rope at the person's feet makes an angle of 20 degrees. So, if this is 20 degrees, here, 20 degrees, so 20 degrees yung din, yung nandito. So, it is very important na you draw the coordinates, okay? The x and y coordinates. Yung tuldok sa gitna is the person, okay? Or yung weight ng person. So, weight down. And then, there's this tension in the head part and tension in the foot part. So, feet pala. So, pag dinraw mo siya, ganito yung kailangan ma-picture out ninyo para maintindihan nyo kung saan yung 40 degrees. And then, alam natin sa geometry na magkapareho itong angle na to. So, 40 degrees din siya dito. Then, 20 degrees. Then, dito is 20 degrees din. Now, since we will be dealing with forces, it is convenient for us to express the mass of the person as a weight immediately. So, weight, okay? Now, we have 68 kilogram times 9.80, okay? To have your weight na 666 Newton. For the x component, there is this T2x, okay? T2 with its x, and that is t cosine theta or T2 cosine theta. So, ito yan siya. Well, dito ginamit is phi, okay? Angle phi, and angle theta. Wala namang, not necessarily mag-focus ka sa theta. It's just that, ito yung label na ginawa mo. So, for your phi and theta, ibig sabihin magkaibang angles. Okay, theta is for the 20 degrees and yung phi is for your 40 degrees. It's up to you paano mo i-label yung mga angles mo. So, T2x is T2x is equals to T2 cosine phi, okay? And then T1x is T1 cosine phi, theta. Okay? For the y components naman, kita nyo dito for this tension lang ha. So, si T2y is equals to T2 sine phi. So, ito siya. Then, si Ty1 is T1 sine theta. Now, we all have that forces. We can now go to the summation of all forces along the x. That's 0. So, all forces along the x is this T2x, okay, minus T1x. And they are equivalent to this angle, no? And then, you simply input T2x minus T1x equals 0. Or, pag ilipat mo siya sa kabila, magiging positive si negative. So, T2x is just equal to T1x. Or, T2 cosine phi is equal to T1 cosine theta. For the y components naman, kita nyo sa figure, merong T2y plus T2y1 minus W, okay, equals 0. So, ito na yan siya. Now, since negative siya, ilipat mo sa kabila, magiging positive. And then, ang value ni T1y is T1 sin theta, T2y is T2 sin phi. Since you have your equations na, you can input, no? You can input the given data. Ano bang given data natin dito? Angle lang at yung mass, okay? Dalawang angle at yung mass ni person. So, hindi pa sapat. Hindi pa sapat yung equation natin para ma-solve yung T1 and T2. Meron na tayong value ni ni weight, pero wala tayong value kung ano si T2 and T1. I guess ito yung question. Find the tension in the two ropes. So, find the T2 and the T1. So, we have two unknowns and then we also need two equations. So, we have two equations na. So, since given tayo ng weight, okay, and given din tayo nito, ang unknowns lang dyan is T1 and T2. We can find ways, okay, to figure out paano. Let's say, ang ginamit dito is equation na ito, okay? Paano mo gagamitin? Kukuha ka ng isang variable, let's say, ginamit niya dito T2, okay? Kukunin mo yung isang, hindi siya variable, isang constant, like T2 value. So, value ni T2, pag ilipat mo yung cosine phi sa kabila, magiging denominator. So, T2 is equals to T1 cosine theta over cosine phi. Okay? So, ganyan na siya. Ngayon, yung value ng T2 na yan, para magkapareho sila dito, okay, makancel out mo yung T2 dyan, no? Ang matitira is puro T1. I-insert mo si value ni T2 dito sa isa. Okay? Ganun lang naman. Two unknowns, two equation, you only need to do your way. Okay? It's your own way. Sa pag-solve dito sa book, ginamit niya na value is T2. Then, yung T2 na value dito sa equation 1 is in-insert niya dito sa equation 2. Now, pag insert niya, ito na siya. Okay? T1 sin phi, sin theta, okay, tama. Plus, yung T2 na value, T2, okay. Stay mo lang yung sin phi. Ayan siya, sin phi. And then, sin phi, and then, in-insert mo itong T1 cosine theta over cosine phi equals W. Now you have your equation factoring out the T1, okay? Makukuha mo na ang value ni T1. Bakit? Given tayo ng angles and given tayo ni weight. Now, to factor out the T1, okay, pareho silang may T1, so ilalabas natin si T1, no? And si sin theta plus, copy plus, cosine theta over cosine phi times sin phi. Kaya siya ganyan, equals W. Now, to solve this equation, ibaba mo ito na part, ibaba mo yan na part, ito na part. Okay? W over, yan siya na part. Para makuha mo yung equation 5.31. Now, input values, okay, ni weight, ni angles, and you will get the tension 1 na 589 Newton. Ngayon, meron ka ng value no T1. Saan mo siya pwedeng input? Again, pwede mo siyang input dito. Pero hindi, pwede mo na siyang input dito na equation, okay? Or dito na equation. Pero doon ka na mag-input sa di ba ito is ginawa mong ganito. So, input mo na siya dito, T1 na value, then cosine theta over cosine phi. You will get the value for the tension 2. Okay, ito na siya, oh. Now, ito ginamit niya dito is equation 5.11. Dito. Ito yung kanina, T2, then T1, cosine theta, cosine phi, and then yung value ni T1, then again yan, you will get T2. Note that the tension in each rope is different. Bakit? Kasi magkaiba rin sila ng pagka-angle. Okay? 589 versus 723. Okay? The ropes that are used for this hammock must be capable of withstanding this tension or they will break. Next. An interesting special case arises when the angles theta and phi are equal. So, paano kung pareho ng angle yung pagduyan mo? Dito, let's say they are both 20 degrees or they are both 40 degrees. Paano yung equation na mangyayari? So, since equal yan sila, cosine theta over cosine phi, okay, this is from your equation kanina na na-solve ito. So, that is 1. Okay, kasi nga pareho sila. So, T2 is equals to T1. That's the time na magkapareho na yung value ni tension 2 at ni tension 1. Of course, dahil pareho na sila ng angle. So, proceed. Section 5.2, the concept of torque. Let us now consider the familiar seesaw you played on an ideal schoolyard during your childhood. Suppose a 30-kilogram child, yung M1. Saan ito si M1? I think this is M1 because it has weight 1. Is placed on the left side of a weightless seesaw and another 20.4 kilogram M2 is placed on the right side as shown in here. So what are their weights? Simply multiply each of their masses to the gravity, which is this. So, weight 1 is 300 Newton and weight 2 is 200 Newton. Obviously, mas mabigat si weight 1 or si child na nasa left. Okay? So, exert forces down on the seesaw while the support in the middle exerts a force upward. There's a force upward here. So, the weight of both the children, okay, nung mga bata is pulling the seesaw downward. And the forces acting on this seesaw is only yung nasa gitna. That is why meron siyang force upward. According to the first condition of equilibrium, okay, summation of all forces along the y is 0. The body should be in equilibrium. However, we know from experience that if a 300 Newton child is at the left end and a 200 Newton child is at the right end, the 300 Newton child will move downward while the 200 Newton child moves upward. That is, the seesaw rotates in a counterclockwise direction. Anong counterclockwise? Kasi di ba ang clockwise is parang sa clock. So, since mas mabigat si W1, it will rotate counterclockwise. Okay? Now, it is obvious that the first condition of equilibrium is not sufficient to describe this equilibrium. So the first condition takes care of the problem of translational equilibrium. What is this translational equilibrium? It says that nothing about the problem of rotational equilibrium. It is also what we call rotational equilibrium. So, forces acting on a body that do not all pass through one point of the body are called non-concurrent forces. Hence, even though the forces acting on the body cause the body to be in translational equilibrium, the body is still capable of rotating. Therefore, we need to look into the problem of forces acting on a body at a point other than the center of the body. So to determine how these off-center forces cause the rotational of the body, and finally to prevent this rotation so that the body will also be in rotational equilibrium. To do this, we need to introduce the concept of torque. So, nandito na si torque. Torque is defined to be the product of the force times the lever arm. Okay, so magmamatter na yung lever arm or kung gaano layo. Si torque, now, the lever arm is defined as the perpendicular distance from the axis of rotation to the line along which the force acts. Perpendicular, big sabihin, ayan, kung paganyan siya, hindi mo siya pwedeng i-parallel. So, ito siya, perpendicular. That's the lever arm. Next, the force line of action of a force passes through the point of application of the force and is parallel to F. Parallel daw kay F. Ito siya. So from this equation, if we subtract them, it will be like this. But the net torque is this difference between the counterclockwise and clockwise torques, so that the second condition for equilibrium can also be written as, for a rigid body acted on by any number of torques, the condition for that body to be in rotational equilibrium is that the sum of all torques acting on that body must be 0. And that is, summation of all torque acting on that body is equal to 0. So, since the torque is about an axis that is perpendicular to the plane of the paper, and since the plane of the paper is the x and y plane only, the torque axis lies along the z-axis. Hence, the torque can be represented as a vector that lies along the z-axis. Thus, we can also write equation 5.25 as like this. So, in general, torques can also be exerted about the x-axis and y-axis. And for such general cases, we have summation of all torque in the x-axis equals 0 and summation of all torque in the y-axis equals 0. So, depende sa tatlong ito, 3 axes. However, in this text, we will restrict ourselves to the forces in the xy plane and torques along the z-axis. So, xy plane, okay, yung sinabi kanina about sa papel. So, si torque is perpendicular sa plane. So, it can be the x-axis. Section 5.4, equilibrium of a rigid body. In general, for a body that is acted on by a number of planar forces, the conditions for that body to be in equilibrium are this. Summation of all forces along the x and the y is 0, and then summation of all the torques in the clockwise is equals to the summation of the torques in the counterclockwise. So, this is the most common equation na gagamitin natin. The first condition of the equilibrium guarantees that the body will be in translational equilibrium, while the second condition guarantees the second body is in rotational equilibrium. The solution of various problems of statics reduced to solving the three equations 5.5, 5.4, and 5.25. Section 5.5 is devoted to the solution of various problems of rigid bodies in equilibrium. So, we are now in section 5.5, examples of rigid bodies in equilibrium. There are parallel forces. So, two men are carrying a girl. Two men are carrying a girl on a large plank that is 10 meter long and weighs 200 newtons. So, this is a plank na 10 meter. Ito yun siya, 10 meter long. And a girl that weighs 200 newton. Okay, the weight of 200 newton is nung plank. Okay, so gitna ng plank, nandyan yung center of mass ng ating plank. So, nandyan yung kanyang weight. Okay, weight of the plank is 200 Newton. If the girl weighs 445 Newton and sits 3 meter from one end, so this is one end, 3 meter from this, okay, nakaupo si girl na may weight na 445 Newton. How much weight must each man support? So, ano yung F2 and F1? Yan yung forces na kailangan nilang i-exert or i-support para ma-karga nila si girl. Now, for these distances, okay, 3 meter minus 10 is 7. So, this is 7. And then, yung gitna is 5 meter. As you can see, for the torques computed about point A. So, where is our point A? Let's say, this is our point A kay boy or kay bapa sa left. Okay, this is for A. Now, we have F1. Okay, pataas. Kasi yan yung force na ini-exert niya doon sa plank and doon sa bigat ni girl. So, there's this F1. And then, yung distances niya is 5 meter. And then, may 7. And then, may 10. Okay? And then, kapag dito naman tayo sa torques computed about point B, sa kabila, merong 3, merong 5, at merong 10. So, kung saan ka nagbe-base ng point, doon ka magsisimula ng counting para doon sa mga forces. Now, the first thing we note is that the body is in equilibrium and therefore, the two conditions of equilibrium must hold. The first condition of equilibrium, equation 5.5, applied to this figure is summation of all forces along the y is equal to 0. So, F1 is positive, WP is minus, WG is minus, and F2 is positive. So, F1 plus F2 minus WP minus WG is equals to 0. Or pag ilipat mo yun sila sa kabila, magiging positive. F1 plus F2 is equals to WP plus WG. Or 200 Newton plus 445 Newton is equals to 645 Newton yung F1 and F2. So, meron ka ng equation 1. Ano nga yung hinahanap dito? 2 forces. So, F1 and F2, we have 2 unknowns. So, we also need 2 equations. So, we have our first equation na. Okay? Since there are no forces in the x direction, we do not use equation 5.4. Okay? So, ang equation lang na gagamitin natin is equation 5.5 for these y components. Ito nga, ito sila. For the x component, y components, and the torque. So, equilibrium ng torque is equation 5.24 kanina. Ito siya. Now, we see that the torque the clockwise and is equals to the torque counterclockwise. However, before we can compute any torques, we must specify the axis about which the torques will be computed. So for now, let us consider that the axis passes through the point A. So ang ginawa ng nag-compute dito sa libro na to is doon siya nagbase sa point A dito. Okay? So, torque clockwise. Paano nga yung clockwise? Mag-iikot siya according kay clock. So, ano yung clockwise na forces dito? Itong pababa, si WP. And si WG. And also si F1. Okay? So, since nasa point A tayo, di ba? Kapag 0 yung lever arm distance nung force, this means that F1 is also, the torque at F1 is 0. So, ang torque na mako-consider lang natin dito is yung away from that point, which is this one, and this one. So, the torque that is clockwise is WP and WG. Okay? So, WP and WG. We know from this picture na merong distance dito na 5 meter and si WG is 7 meter. So, input 5 kay Planck, weight ni Planck, at kay G na 7 meter. And then, doon sa counterclockwise is si F2. That is 10 meter from this point. So F2, 10 meter. By the way, you can solve this problem when you are to use point B. Okay? So, sundan na lang natin yung ginawa ng nag-solve dito na nasa point A siya nag-solve for its torque. Now, we have this one. So, sinimplify niya, okay, to have a second equation. Dito, ginamit niya is F2. Kasi given na to. WG, given yan. And si Whitney Planck also given. So, ang F2 ang wala. Now, we can compute for the value of F2, pag ibaba natin sa 10 meter dito, or overall 10 meter. So, it can be like this. And then, input the value of the weight of the plank and the weight of the girl. You can get that the force 2 is 411.5 Newton. Now, you have the value for F2. You can have now the value for F1. Anong equation yung ginawa mo kanina? Eto, equation 1. Okay? So, di ba dalawang unknown? So, we also need two equations. So, sa second equation mo, nakuha mo na yung value ni F2. So, wala ka nang isosolve kundi ang bumalik ka sa equation mo na una and then insert mo yung value ni F2. And you can get the value for F1. And that is like this. So, you can get 233.5 Newton. The first man exerts an upward force na 2335 Newton while the second man carries the greater burden of 411.5 Newton. Bakit? Obvious naman kasi mas malapit sa kanya itong babae. So, ito magaan lang dito and then dito medyo mabigat or mabigat yung support or mas malaki yung force na kailangan niyang isupport para makarga itong plank at si girl. In general, whenever a rigid body is in equilibrium, every point of that body is in both translational equilibrium and rotational equilibrium. So, any point of that body can serve as an axis to compute torques. Even a point outside the body can be used as an axis to compute torques if the body is in equilibrium. So, ito yung sabi ko kanina, at any point of that problem of or the picture, you can compute torque. Okay? So, pwede kang mag-compute na F2 yung panggagalingan mo. Okay? Pwede ka rin mag-compute dito. Pwede ka rin mag-compute dito. At pwede ka rin mag-compute dito. But, to make it easier, maghanap ka kung saan yung point ng reference mo na available lahat. Okay? So far, kay A or kay B, available lahat. Kasi given yung weight ni plank at weight ni girl. So, diskarte mo paano isolve yung mga ganitong problem. But for simplicity, always look for simpler setup. Next is the center of gravity of a body. A meter stick of negligible weight has a 10 Newton weight. So, hung from each end, where and with what force should the meter stick be picked up such that it remains horizontal while it moves upward at a constant velocity? This problem is illustrated in here. So there's this 10 meter stick, a meter stick of negligible weight has a 10 Newton hung from each end. So si meter stick, meron siyang 10 Newton na weight hanging from each end. Okay? So, paano mo malalaman kung saan yung center of gravity ni meter stick? Simple lang, sa gitna. Okay? Sa gitna ng meter stick. So, this can be where sa illustration B is kung saan yung weight. Okay? So, the weight 1 and the weight 2, okay, must be at the end, no? Then, there is a force. Where and with what force should the meter stick be picked up such that it remains horizontal when it moves upward? So, dito sa problem na to, ginawa niyang length is 100 cm because a meter stick is always 1 meter. Okay? So 1 meter is equivalent to 100 centimeter. And of course, by this illustration, we see that the summation of all forces along the y is F minus 1, W1 minus W2 is equals to 0. So ito na siya. Input the value of 10 and 10, so you get a force na 20 Newton. For it to have an rotational equilibrium, we use equation 5.24 na torque at clockwise is equal to the torque at counterclockwise. Taking the left end of the meter stick as the axis of rotation, so this is where is kumaga yung origin or as your axis of rotation, you can see that there is an F and there is a W. Okay? So, ang clockwise mo dito is si W. So, that is W times 100 centimeter or W times the L is equals to counterclockwise mo si F. Okay? Pa-counterclockwise siya. So, mayroon siyang distance X. So, this is now your second equation. Okay? Sa first equation mo, alam mo na yung F. Sa second equation mo naman is ito. So, meron ka ng value ni F, meron ka ng value ni W2, and meron ka na ring value ni length ng meter stick. Ang kulang na lang is yung value kung saan nakapwesto si force mo. So, when you input those values, solving for X only, baba mo yung F, so you can get W2 times the L over the F. And you can see that 50 centimeter. The meter stick should be lifted at its exact geometrical center. So, this is why nasa center siya nung meter stick for have the center of gravity. Okay? Center of gravity of a body. Okay? Now, this point that behaves as if all the weight of the body acts through it is called the center of gravity. Okay? Abbreviated as CG of the body. Hence, the center of gravity of the system, in this case, a meter stick and two equal weights hanging at the ends, is located at the geometrical center of the meter stick. That is because center of gravity niya is sa gitna dahil pareho lang naman din yung weight na nakahang on both sides. What if ito mabigat and what if ito magaan? That's the time na center of gravity ng ating meter stick is hindi na sa gitna, but it can be anywhere here. Example 5.4, the center of gravity when there is no symmetry. Okay, ito na, no symmetry. If weight W2 in the preceding discussion is charged 20 Newton, where will the center of gravity of the system be located? Now, iniba niya na. Okay? Si W1 is still 10 and W2 is 20 na. Where is this force na kung saan ipipick up mo siya and hindi siya iikot? Magkakaroon siya ng rotational equilibrium pa rin kahit halimbawa kapag dyan mo siya i-pick up. So, what is the X now? So, you have summation of all forces along the Y kanina. So, since 10 plus 20 na siya, you have the force na 30 Newton. And input that on the equation nung kanina rin, na second equation mo, you have 20 Newton times 100 over 300. Now, your X is 66.7 centimeter. And that is somewhere in here. Okay? Kasi ito is 50 centimeter. Big sabihin, si force mo is somewhere in here na 60 plus. Kasi ang origin mo is nandito sa W1. So, that is 66 centimeter away from that axis. Okay? Now, general definition of the center of gravity. In the previous section, we assumed that the weight of the meter stick was negligible compared to the weights W1 and W2. Suppose the weight W1 and W2 are eliminated and we want to pick up the meter stick all by itself. The weight of the meter stick can no longer be ignored. But how can the weight of the meter stick be handled? In the previous problem, W1 and W2 were discrete weights, okay? Here, the weight of the meter stick is distributed throughout the entire length of the stick how can the center of gravity of a continuous mass distribution be determined instead of a discrete mass distribution? From the symmetry of the uniform stick, we expect that the center of gravity should be located at the geometric center of the 100 centimeter meter stick. That is at point X na 50 centimeter or kalahati, di ba? At this center point, half the mass of the stick is to the left of the center, while the other half of the mass is to the right of the center. The half of the mass on the left side creates a torque counterclockwise about the center of the stick, while yung isa is clockwise na torque. Thus, the uniform meter stick has the same symmetry as the stick with two equal weights acting on its ends, and thus have its center of gravity located at the geometrical center of the meter stick, the 50 centimeter mark. Now, the Greek letter sum of, okay, this is the Greek letter, this is basta ganun, against, then this is mean the sum of, okay? So, from this shorthand notation, the W1, ito, W1, W2, W3, in-add up mo siya, okay? And you will get the summation of all the weights when I is equal to 1. Okay? To N. So, we don't know what is N, okay? Kasi, it can be 100, it can be, kung ganun, kung gaano ka layo or kung gaano kataas si N. Now, using this notation, the first condition of equilibrium becomes the forces is equals to summation of all the weights, or simply W. The sum of these Wi's is equal to the total weight of the meter stick W. Okay? So, force is just equals to the weight. Now, the second condition of equilibrium, yung summation of all the torques in clockwise is equals to summation of all the torques counterclockwise when applied to the meter stick, and when this axis taken at the zero of the meter stick yields this one. Okay? The general expression for the coordinate of the center of gravity of a given body, is given by this, okay? X, center gravity, okay? Distance wherein nasaan yung center of gravity is equals to the summation of all the weights, okay? Of all the weights and its distance, this is a torque, diba? All over the total weight, no? So, since W1, W2, W3, W4 are all equal, and you have W10, no? So, we can have weight is divided by, or the total weight is divided by 10. It can be factored out by giving this one. So, W over 10, okay? Or simply, cancel the W and 1 over 10, okay? So, 1 over 10 times, ano yung kanina? Yung xi mo. Ano yung xi mo? That is x1, x2, x3, x4 hanggang x10. So that is this uniformly distributed, diba? So that you have 5, 10, 20, 30, 40 up to 100. So you have up to 95, and then you add that up and then divide by 10, and that is 50 centimeter. Now, the center of gravity of the uniform meter stick is located at its geometrical center, just as expected from the symmetry considerations. Now, to find the center of gravity of a two-dimensional body, the x-coordinate of the center of gravity is found from equation 5.31, while the coordinates found is in analogous manner. Okay? If you are talking about the x-axis, you use 5.31, okay? And when you are to use for the y-axis, you also have to use this equation 5.32, but they are just analogous, okay? In a manner na magkaiba lang yung axis of consideration. Now, for a non-uniform body or one with a non-symmetrical shape, the problem becomes more complicated with the sums in equation 5.31 and 5.32 becoming integrals and will not be treated in this book. So we will no longer discussing about integrals, but we assume that on all the problems here in the topic is uniform yung isang object. Example, illustrating the concept of the center of gravity. A weight of 15 Newton is hung from one end of a uniform beam. Okay, it is uniform, okay? 12 meter long. If the beam weighs 25 Newton, where and with what force should that beam be picked up so that it remains horizontal? The problem is illustrated in figure 5.17. So this is the beam na merong weight of 25 Newton. So sa gitna ng beam nakalagay si 25 Newton. And it is 12 meter long. Okay? Sa gitna ng 12 meter is 6 meter. So there is a 15 Newton hung from one end of a uniform beam. 15 Newton weight, okay, from one end of a uniform beam. So, pwede mong ilagay ito dito, pwede rin dito. So, nilagay ni writer dito sa right hand. So, si weight dito is 50 Newton, okay? Now, the question is where and with what force should the beam be picked up? Pag ikaw ba kakargahin mo na yung beam, saan mo daw siya pupulutin or saan mo siya hahawakan para makuha and it will remain horizontal, meaning hindi iikot, hindi siya mag-move. So that is X, okay? X kasi hindi pa natin alam and that is also a force. So there are two unknowns. There's this unknown na X and unknown na F. So we need two equations. For the first condition na summation of all forces along the Y, we see here in this illustration that F, okay, minus WB and minus the W1 is equals to 0. Ito na siya. So, pag ilipat mo yung dalawang W sa kabila, you will get that the force is 25 plus 50. Okay, kasi given na 25 and 50, and that is 75 Newton force. So, you have to exert a 75 Newton force. Ang question is, saan banda sa beam? Okay? Now, for the second condition, that the all torques along the clockwise is equals to the torques along the counterclockwise, we see that ang point of reference niya dito is yung kung saan naghang yung 15 Newton weight. Now, we see that the forces acting or the torque acting on the counterclockwise is WB. Okay, bakit gaganon niya siya? That is a counterclockwise. So, 25 Newton or WB times the L na kalahati. So, that is 6 meter. Ang ginawa lang niya dito is WB tapos L divided by 2. Thus, the center of gravity of the system is located at this X. So, baba mo si F. It can be W, L half over F. And that is equals to 2 meter. Therefore, we should pick up the beam 2 meter from the right-hand side with a force of 75 Newton. So, this is a 2 meter ka from this point. So, you are picking up a 75 Newton force 2 meters from this right. Another example, the front wheels of an automobile when run onto a platform scale are found to support 8,010 Newton, while the rear wheels can support 6,680 Newton. The auto has 2 meter wheelbase distance. Okay, so this is wheel to wheel, so 2 meter. Locate the center of gravity of the car, and the car is shown in this figure. Pag sinabing front wheel, front. Pag sinabing rear, likod yan. Okay, rear. So, sa likod is meron tayong 6,680. So, from this from this situation, summation of all forces along the y, Fn2 plus Fn1 minus W equals 0. Okay? Now, this will look like this. Fn1 plus Fn2 is equals to W. Nilipat mo lang siya sa right hand. Now, we have the value for Fn1 and Fn2 na 810 at saka 6680 Newton. So, you have a weight na 14,700 Newton. Ang tanong, saan banda siya nakalocate sa car? Kasi hindi uniform yung ating car. May isang mabigat. Okay, sa harap is mabigat, sa likod is magaan. So, what is the X? Okay, so dito ang ginawa is point from the right side. Okay? Now, summation of all the torque clockwise is equals to summation of all torque counterclockwise. So, from this point, you see that the clockwise is Fn2. Iikot yan siya pa ganyan. Okay, so that is 2 meters from this point. Fn2 times 2. Okay, so yan na siya. And then, ito naman is W. That is counterclockwise. So, equal to W times the X. Okay, now, solving for the X, baba mo si W, and you get Fn2 times 2 over W. You get that the center of gravity of the car is 0.910 meter from this right side. Okay, so from, nandito siya. Center of mass. The center of mass of a body or system of bodies is defined as that point that moves in the same way that a single particle of the same mass would move when acted on by the same forces. Hence, the point reacts as if all the mass of the body were concentrated at that point. All the external forces can be considered to act at the center of mass when the body undergoes any translational acceleration. The general motion of any rigid body can be resolved into a translational motion of the center of mass and the rotational about the center of mass. On the surface of the Earth, where gravity G, the acceleration due to gravity, is relatively uniform, the center of mass of the body will coincide with the center of gravity of the body. And to see this, we take equation 5.31 and note that weight is equals to mass times gravity. Okay? Substituting this into equation na 5.31. Yung 5.31, ano nga yung 5.31? We have solved this a while ago na. Ito siya. Okay, summation of all the torques along the X. Okay? Now, we see that X is equals to summation of Wi over the total weight. Okay? Summation of all the weights. Now, we know that weight is equals to mass times gravity. So, we input MIG, XI. G is the same, so you can cancel that out. And the right-hand side of the equation ng ito is defining the relation for the center of mass of a body and we'll write as ganito. So, summation of all the masses and its distance all over the total mass. Okay? So, equation 5.34 represents the x-coordinate of the center of the mass of the body. So, we obtain the same analogous for the y-coordinates. Okay? Y is equals to summation of all the masses along the y and all over its total mass. Finding the center of mass. 3 masses, M1 20 grams, M2 40 grams, M3 5 grams are located on the x-axis at 10, 20, and 25 respectively. So find the center of mass of the system. Now, from using this equation 5.34, we know that the total mass is 20 plus 40 plus 5, and that's 65. And Mi is 20, okay? 20 times 10, okay? 40 times 20, and 5 times 25. Okay? Input that into this equation, you get that. Okay? Summation of all the mass times its distance. Okay? All over the total mass. You see that 17.3 centimeter is the center of mass of the three masses. Okay? Ito yan siya. Yung illustration niya. The crane broom. What is a crane broom? Ito yan siya. Si crane boom. Crane boom. A large uniform boom is connected to a mast by a hinge pin, okay, at a point A. Where's point A? This is the hinge. Okay? And a load, WL, ito si WL, ayan no, ayan siya, is to be supported at the other end B. So this is the point A and point B. A cable is also tied to B. This is the cable and is connected to point C to give additional support to the boom. Okay? We want to determine all the forces that are acting on the boom in order to make sure that the boom, hinge pin, and the cable are capable of withstanding these forces when the boom is carrying the load. So, importanteng malaman din natin na ano yung maximum capacity ng ating crane boom para hindi masira or hindi ma-damage yung ating crane boom. Of course, we apply this equation, summation of all forces along the y, summation of all the forces along the x, and summation of all the torques clockwise equals summation of all the torques counterclockwise. So by using summation of all forces along the y, we see that there is a V. Okay? What is this V? Denoted as vertical force acting on the end of the boom. So there is a force here. Ito is a hinge. Hinge pin, ibig sabihin, iikot yan siya, ganyan. Okay? It will freely ikot-ikot like this. Joke. So, there is a force vertical and a force horizontal. Okay? So, dito naman kay WL, since kailangan na may mag-support dyan, ito, merong nag-support na, anong tawag dito? A cable. Okay, sa cable, merong tension. So, si tension is naka-angle. So, we have Ty and Tx. Okay? So, we have equations along the y-axis, V plus Ty. So, you see that from this figure, Ty is equals to T sine theta. Right? Ty, okay, ayan o. Ty is equals to T sine theta. And minus WB and minus WL. So, that is the forces along the y-axis. Ayan siya. Okay? So, ilipat mo yung dalawang negative sa kabila para maging positive. Now, for the x forces along the x-axis, we have meron. Kasi meron tayong horizontal forces dahil sa hinge pin and also horizontal forces dahil kay cable na Tx. So, positive si H and minus si Tx. And that is T cosine theta. Okay, so that is equal to 0. H minus Tx equals to 0 or H is equals to T cosine theta. Bakit? Kasi inilipat mo si minus Tx sa kabila. Now, you have two equations na. Okay? For these two unknowns. So, you have this equation 5.36 and this equation 5.37. Bakit two unknowns? Okay, sa problem kasi, binigyan tayo ng weight ni hinge. Sige, let's just proceed. Now, substituting the values, dito tayo. There are two unknowns in this equation, namely the the horizontal force and the torque. Okay? The tension, H and T. Ano si H? Si H is the horizontal force doon sa hinge pin and si torque. Yan yung wala. Now, Balik tayo sa problem. Because weight nung ating B and weight L are known. No? Now, the left-hand side contains the two unknowns, Vt, so we cannot proceed any further with this equation at this time. Okay? Kaya nagkaroon ng second equation. So, first equation and second equation para ma-solve ang two unknowns. Now, for the I think this is summation of all the torques along the clockwise is equals to summation of all the torques along the counterclockwise. Ginawa niyang WB times 1/2. Clockwise ba siya? Okay, clockwise kasi dito tayo point of reference is sa A. So, WB kalahati ni L times kalahati ni L plus WL times TL. Sana siya. Kaya ganyan. Equals, eto, counterclockwise si TY. So, TY times DL. So, we have this one. We know that TY is equals to T sine theta. Okay? Solving for the T, okay, the T, we can see that ibaba mo lang si sine theta L, okay? All over sine theta, okay? L is magiging ganito. Bakit nawala si L? Kasi parehong may L, and then may L. So, pwede mo silang i-cancel out. Given na lahat sila may L, okay? So, ang natira is WB over 2 plus WL all over sine theta. And input the value, okay? And the 30 degrees dahil doon sa cable, and you get that the tension is equals to 2070 Newton. Now, the tension in the cable is 2070 Newton. We can find the second unknown force na H. Okay, ano nga si H? Si horizontal force dahil dun sa hinge. Gamit itong second equation mo. Ano nga yung second equation natin? Ito. First equation is ito. Okay? Now, inputting the value for the tension, okay, then cosine of 30 degrees, we see that there is a horizontal force na 1,790 Newton. The horizontal force exerted on the boom by the hinge pin is 1,790 Newton. And we find that the final unknown forces, vertical forces by substituting T into the equation 5.36, okay? If ever gusto mong malaman kung ano yung forces na ito, you can have it by substituting that into this one. Okay? Kasi meron ka ng value ni TY. Meron ka na rin yan. So, you can get that the vertical force is equals to 135 Newton. Next is the ladder. A ladder of length L is placed against a wall, as seen in this figure. So, a person of weight WP ascends the ladder until the person is located at a distance D from the top of the ladder. So, dito siya nagsimula until nandito siya. So, ang weight niya is WP and ascends the ladder until the person is located a distance D from the top of the ladder. So, a distance D, okay, from the top of this ladder. So, this is his distance from the top of the ladder. We assume that the ladder is uniform. Hence, the weight of the ladder WL can be located at its geometrical center sa gitna nung ladder. Okay? So, ito si L. Okay? L. So, sa gitna ni L, nandyan yung kanyang weight. There are two forces acting on the bottom of the ladder, the vertical force and the horizontal force. So, there's a horizontal force and a vertical force. Now, the ladder pushes against the ground, and the ground must exert an equal but opposite force upward the ladder. Kaya meron siyang vertical force. And with the ladder in this tilde position, there's a tendency for the ladder to slip to the left. Okay? There's a tendency na mag-slip siya papuntang left. So, kailangan meron siyang horizontal frictional force na pa-right. Okay? Kaya siya may ganyan. Now, at the top of the ladder, there is a force F on the ladder that acts normal to the wall. Okay? Nakadikit kasi si ladder dito, so there is a normal force para dun sa ladder, and that is perpendicular to the surface of the wall. Now, there is also tendency for the ladder to slide down the wall, and therefore there should also be a frictional force on the ladder acting upward at the wall. Okay, kaya meron din dito, meron dito na frictional force pataas. Okay, kasi may tendency na itong ladder is mag-slip pababa. So, meron rin dapat dito. Now, these equations also hold for solving problems about ladder, okay? So, there is a summation of all forces along the Y. We see that there is V, there is WL, and there is WP. Okay? So, tatlo. V minus WL minus WP equals 0. Or, V is equals to WL plus WP. And the figure also shows that the force to the right is H. Okay? There is a X coordinate forces. Anong meron? Si F at si H. And that is H minus F. Okay? Equals 0. Kaya siya ganyan. H minus F equals 0. Or, horizontal force is also equal to the normal force of the ladder from the wall. It is important that you see how equations 5.41 and 5.42 are obtained from the figure, okay, kanina. This is the part that really deals with the physics of the problem. So, in any problem talaga, you really need to picture out every forces. So, kung kailangan mag-drawing ka. Okay? Not necessarily na maganda. Okay? Importante maintindihan mo kung saan patungo yung mga ginagawa mong computation. Okay? So, since engineering ka, you need to picture out everything. All the forces and all its distances. Kahit wala na itong tao, kahit line-line na lang yan, point-point, importante ma-draw out mo. Now, for the torque, okay? If we drop a perpendicular from the axis of rotation to the line showing the direction of the vector WL, we obtain a lever arm LA, given that LA1 is equals to L1 half cosine theta. Saan yung LA1? Ito, with regards kay weight nung ladder natin, meron siyang distance na LA1, and kay weight ni tao, ni person, is meron siyang distance na LA2. And since that is a perpendicular, okay, ito yung height, ito yung weight, okay, pero yung lever arm is again perpendicular to the force. So, perpendicular siya. So, ito yung point mo. Meron kang LA1 and meron kang LA2. And to get that LA1 and LA2, you see from this figure na may angle. Okay? So, your L is with regard to the x-axis. So, L cosine theta, ang L1 mo. Okay? So, ito, LA1 mo is ito lang. So, that is L1 half cosine theta. Let's see. L1 half cosine theta. While yung isang LA2 is dito, so that is in here. And that is unknown, okay? Hindi mo alam. Pero alam mo na ito is L, or length ng ladder, and ito yung D, na distance ng tao doon sa ladder. Okay, ito. So, that is L minus D. Ibig sabihin ito, na distance is L minus D. So, LA2 is just equal to L minus D cosine theta. Ito siya. So, they are both clockwise, right? Clockwise and clockwise. Okay? Ang point of reference natin pala is nandito ha. Okay? So, meron tayong counterclockwise na force. Saan? Nandoon. Okay? What is the distance of that So, puntang kaliwa si force. So, perpendicular to that is your lever arm from this point. So, that is LA3. Okay? Since LA3 is nasa y coordinates and yung theta natin is nandito, ibig sabihin, you are referring to this line, and what is this line? This is exactly the L, and L sine theta. So, LA3 is equals to L sine theta. Okay, ito yan siya. Now, pagsamahin mo yung torque along the clockwise is equals to torque along the counterclockwise, we can get this equation. Malinaw. Now, a typical problem, let us assume that the following data are given. Okay, meron ng data. 60 degrees. And then yung weight ng ladder natin is 178 Newton. Weight ng person is 712 Newton. And yung length ng ating ladder is 6.10 meter. And yung distance nung tao from the top of the ladder is 1.53 meter. So from this equation, you can simplify this, okay, by solving for f. Ibaba mo lang yung si L over sine theta. Ayan siya. And then all over ka dyan. All over. So, ganyan siya. Now, input values. We have to input the values and we can get that the force is 360 Newton. Now, meron pa tayong tinitingnan na horizontal force. Ano yan siya? From your previous assumption kanina, for all the forces acting on the x-axis, they are just the same. Okay, si force nito is just the same kay horizontal force. Yan ay para hindi mag-slip. Okay, for that force na hindi mag-slip si ladder. Okay, kung masobrahan ka, halimbawa, nag 365 na yung bigat mo or yung computation mo, and then yung kaya lang i-hold ng ladder na yan is 360 Newton. That's the time na mag-slip yung iyong ladder. Okay? Kaya importante ang ganitong computation kapag in real life situation. Kailangan naka-indicate sa mga bagay-bagay, yung mga maximum na kayang gawin ng isang machine, yung mga minimum, ganyan. Kaya may max and minimum para hindi mo halimbawa 360 lang yung maximum and then nagsobra ka ng 365. Possible na sa case ng ladder mag-slip, no? Now solving for V from equation 5.41, ito yung along the forces along the y-axis. Ito siya. You can get the vertical force, okay? And inputting the values, ayan siya, that is 890 Newton. As a variation for this problem, we might ask, what is the minimum value of the coefficient of friction between the ladder and the ground? No? Now, you can see that from this problem, there is a horizontal force in here na may kinalaman sa friction. And what is that friction? Static. Bakit? Stay put lang kasi si ladder natin. So, we have to compute for this mu static. Okay? So, horizontal force is just equal to the frictional static force. And that is equals to mu s times the normal force na n. Okay? We know that this is a vertical force. From here, okay? From here, ano yung Fn dito? Syempre, yung pataas. Normal force is the vertical force. So, that is why V siya. Eto, V. Since Fn is just V, ayan na siya. So, mu s is equals to horizontal force over the vertical force, and that is 0.404. And if mu s is not equal to or greater than 0.404, then the necessary friction force H is absent and the ladder will slide out at the ground. Okay? For these applications of a theory of equilibrium to the health sciences, okay, understand it on your own kasi madali na lang siyang intindihin. Given na naintindihan nyo rin yung lesson natin. And then, I think this is the last topic. So, the language of physics. Okay? And questions for these chapters, ipopost ko na lang. And if you have any questions regarding this topic, you may reach to me through our group chat. Thank you for listening and have a good day.